Virtually all Goldax sewer locating systems use the same general principles to accomplish their tasks. In a typical application, a transmitter is inserted into the sewer line from some access point, such as a commode or a sewer cleanout. Once the transmitter is positioned in the place of interest, a receiver is used to scan for its location from above ground. The receiver can surmise the exact location, depth, and direction of the sewer line. In order to understand how the receiver is able to do this, it is important to first understand how the transmitter works. In general, a sewer transmitter sends a signal pattern that aligns with its direction. The transmitter's direction is considered to be along the lengthwise axis of the transmitter. When activated in the sewer line, the transmitter creates 4 points of reference around itself, positioned as shown here. These reference locations are called nulls, or dead spots, for reasons that will become obvious later. Notice that these nulls appear in 2 pairs, one pair directly in line with the transmitter, and the other pair directly straddling the sides of the transmitter. The nulls straddling the sides of the transmitter are called side nulls. The nulls that are in line with the transmitter are called end nulls. If a line is drawn through the side nulls, line A, and a second line is drawn through the end nulls, line B, then the transmitter itself is located at the intersection of these 2 lines. Line B always will align with the direction of the transmitter. Since the direction of the transmitter will often match the direction of the sewer line that contains it, line B will almost always align with the direction of the underground sewer line as well. The transmitter also creates another pair of reference nulls called depth nulls. As their name implies, these nulls allow for depth measurement. We will discuss depth measurement later. First, let's see how to use the receiver to find the 4 location nulls around the transmitter. To find the side nulls, place the receiver's antenna in the vertical position. Set the sensitivity of the receiver to low and turn the gain all the way up. Scan the area until a sudden dead spot in the signal occurs. If no dead spot occurs, then lower the gain and try again to find a dead spot. This break in signal is the first side null. Pinpoint and mark this null. To find the other side null, walk a roughly circular path away from the first mark. Continue on the circle until a second dead spot occurs. This is the location of the second side null. Mark this location like you did the first. Note that these marks are directly opposite each other on an imaginary circle around the transmitter. Draw line A through these 2 marks. To locate the end nulls, place the detection antenna in the horizontal position, forming a T. Hold the antenna parallel to line A and back away several feet. Again, turn the gain up on the receiver. Now, holding the receiver in this orientation, walk parallel to line A until a signal null occurs. Mark this spot. It is the first end null. To find the other end null, repeat this procedure on the other side of line A. You have now located both end nulls. Draw line B through this pair of null marks. The transmitter is located at the center of the cross formed by line A and line B. Now, let's review how the receiver can be used to measure the depth of an underground transmitter. Although the transmitter in this tutorial is not buried, the proper conditions of a buried transmitter have been simulated for the sake of this demonstration. The depth nulls must be found in order to determine the depth of the transmitter. To find the first depth null, hold the horizontal detection antenna directly above the location mark and aligned with line B. With the sensitivity of the receiver on low, turn the gain of the receiver all the way up. Now, slide the receiver to one side of the location mark and along line B. When a dead spot occurs, pinpoint and mark this location. This is the first depth null. To locate the second depth null, repeat this procedure on the opposite side of the location mark. The exact depth of the transmitter can be calculated from the distance between the depth nulls. Once you have measured this distance, use the depth calculator to relate the surface distance to the transmitter depth.